Okay, here we're looking at carboxylic acids. Carboxylic acids are alkyl groups, which is indicated by the R here, which is connected to a C-double-O bonded oxygen and an OH group. So the carboxyl group, the functional group, is known as carboxyl, and it has C-double-O-OH. Let's have a look at some examples of carboxylic acids. The first carboxylic acid in the family is called methanoic acid. It has the molecular formula CH2O2. Now, so we have a central carbon atom, and start by drawing the functional group C-double-O-C-O-OH, and there's only one carbon in methanoic acid, and therefore the remaining position or the remaining bond is connected to a hydrogen atom. The condensed formula is therefore HCOOH. Now, methanoic acid is commonly found in ant bites. The second member of this family is called ethanoic acid, with the molecular formula C2H4O2. So when we draw the structural formula, start by drawing the functional group and working backwards. So C-double-O, O, and H. So we've used up the 2 oxygen, 1 hydrogen, and 1 carbon. So that remains is a carbon with the 3 hydrogen. So the alkyl group here it's got 2 carbon, therefore is ethanoic, right? Ethanoic, and the condensed formula is CH3. So we're looking at this group of C and 3 hydrogen, CH3, and then COOH. Right, the third member is propanoic acid with the molecular formula C3H6O2. So we start by drawing, once again, the functional group C-double-O-OH, and drawing the remaining carbon backbone, and we have to fill it up with 5 more hydrogens. So 3 around the end and 2 in the middle. So the condensed formula for propanoic acid is CH3, CH2, COOH. Now for carboxylic acid, the functional group is always at the end of the carbon chain, unlike alkanols, where the functional group can be in the center. All right, have a go at completing the table for the rest of this carboxylic acid. And as you know, look at all where these acids are found, and the smell gets progressively worse as the carbon chain gets longer and longer. So you need to also be able to draw isomers of acid if the chains are long. So here are some examples. So see if you can draw the isomers of pentanoic acid, or name them. Actually, this one you have to name them. So use the rules the same way as for naming other hydrocarbons. So start numbering from the functional group N. 1, 2, 3, 4. So this one here is a butanoic acid carbon chain. And it's got a methyl group on the second carbon, so it is a 2-methyl butanoic acid. All right, have a go at naming the other 2 isomer structures. And there's further questions down the page. So drawing out isomers of propanoic acid, showing all bonds, writing condensed formula for each of those isomers, and not all the isomers are carboxylic acid. See if you can figure out which ones aren't and which one are. Let me give you a hint. There's 2 to draw.